Welcome, everyone, and thank you for joining us today. My name is Paul Donahue, and I will be your host. We ask that you please keep your device muted during the session, and if you have questions, please direct them to me via the chat function. We'll do our best to answer questions at the end and to follow up with any unanswered questions via email. As I think you know, these Tech Talks have been designed to provide straightforward insights into radio frequency components, the related technology, and the extra design and engineering value that is added by a custom manufacturer such as Quantic TRM. To begin today's session, I am once again pleased to introduce Quantic TRM's Chief Technology Officer, Shaun Moore. The author of 2 U.S. patents and a number of white papers and technical articles on passive microwave technologies, Shaun has been with Quantic TRM since the late 90s, and his passion for the job and for solving problems has only increased over the years, especially when it comes to resolving our customers' design and engineering challenges. So welcome, Shaun. Can you share an overview of today's topic and your objectives for the session?
Yes, thank you, Paul. Today, we're going to talk about the application engineering process. And really, we're going to start by saying, what is application engineering? And kind of answer that question. And then we're going to go through really why would you want to go through and have an engineer to engineer discussion? Why is it effective? And what sort of advantages does the customer benefit from that? And what benefits does TRM have benefit from that? We'll do a quick review of some of our differentiators that TRM brings to the customer, and then we'll wrap it up with a summary.
Well, that sounds good as usual. So maybe a good place to start then is to define this application engineering process.
Absolutely. So application engineering really has to do with working with the customer, and I think a partnership is not too strong a word to find the best solution for the project that the customer is working on. The customer very often are system engineers, and what they are trying to do is come up with a total solution to the customer. And really what we bring as being a subject matter expert on passive microwave components is that we can go in there and we can work with the system engineer to provide the best possible component to help augment their solution. So really it's the first really the first step in the process to designing the best system is make sure that you have the best architecture set up, as well as making sure that what you're defining can be achieved before you get too far down that drawing board in the system design. The last thing we want to do is have our customers go back and do a redesign because they made some poor assumptions up front. And that's no bad reflection on the system engineers. They just don't have the depth of knowledge on some of our on TRM's components as TRM does.
Well, that makes good sense. So how about the actual process itself? Can you talk a little bit about how that works?
Sure. And the actual process is really it all starts with a conversation between engineers. And that process. It's like I said, it is a conversation, and that's where it all starts off. So really what we like to do and going through this process is go over quickly what are the goals and what is the system engineer trying to achieve with their system or subsystem that they're working on. And part of that discussion very often is, I think it's a very good thing to fully understand what it is the system engineer has in mind, is to do a quick overview of the block diagram of the system, as well as what is this system trying to do? Is it trying to detect a threat? Is it trying to track something? What is it that they're trying to do? Is it a data link? What sort of adverse effects will the system see? What sort of environment is it going to be in? Is this going to be in a high vibration environment, a nasty weather environment, or a high shock environment? Will be in a vacuum? Whatever those things are. Those are all important things to understand from a component level standpoint, to understand what sort of environment that they're going to be in. And the last thing really which I think is critical is, what is important, what's the most important parameter about the system in order for it to accomplish its final goals. And by that, I mean what within the subcomponents of the architecture that the system engineer has worked out will have the biggest impact on mission success. And I think understanding all of those parameters, we can then approach the individual component design to make sure that we optimize all those parameters. And I think that that's a very important thing for people to really understand about why we want to go in there and have this this engineering discussion and not just sell parts. There are many ways to build a lot of these components, and there are trade-offs to be had at every level. And really understanding that level of detail really helps us tailor the solution to optimize all those performance parameters.
Okay, well, that certainly makes sense. But once some of the situational or big picture questions are answered, could you talk a little bit more about some of the specific things that you do and the TRM does to help the customers?
Sure. So once we get past understanding the high level generalities and what's important, we then go through and we talk about the concepts of how the system is going to work. Part of it has a part of, well, if they've proposed a particular component, is that really the right component to achieve what the system designer's intent is? Very often, there are getting down to some subtle performance issues with some of our components. System engineers don't always understand the subtleties, and making sure that we flush those out first. The other thing that we talk about is just basic performance of a lot of our passive components. Again, system engineers aren't always fully in the knowledge as far as performance trade-offs, specifically about bandwidth versus things like insertion loss or VSWR. There are definite trade-offs that need to be made within those bandwidths sort of discussions, and also other performance limitations. Like I said, I certainly don't expect the system engineer to be fully up to speed on the subtle trade-offs that are made within our components, and having that discussion to make sure that what they're asking for really can be built. And I think that's, and whether or not they've asked for a 90-degree hybrid or 180 hybrid or a power divider or a power combiner, what is that really the best component for that particular situation? An example for example, is if you have a redundant local oscillator feeding a system. Very often, people think about having a power combiner and then a power combiner to make sure that a power combiner and then a power divider to make sure that they can combine the signals and then redivide them. If you use a traditional power combiner and then a power divider, you're going to have a 6 dB worth of split between the two oscillators and the two outputs. If you use a 90-degree hybrid, that insertion loss drops to 3 dB, for example. So therefore, understanding those sorts of trade-offs are important. And like I said, and just talking through them to make sure that that the correct component is selected.
So I take it then that either you or your team will sometimes suggest alternative approaches to the customer's engineers.
Yes, absolutely. And I think that's really, the example that I just gave. Really, the configuration of the component is one thing that we need to decide on early on, because that can affect some subsequent system architecture that needs to be that may or may not need to be addressed. These components all work together as a system to solve a particular need, and I think going in there and really working through those discussions is very helpful for the system engineer, because this way here they can make sure that they build the best system possible, and I think it's really something that is valued by the system engineers to have that open discussion, engineer to engineer.
So if I'm getting this right, you're taking on a type of sounding board role in which, as they say, two heads are better than one.
Absolutely, and like I said, this is something that we really value with our customers. We want to complete your ideas. But by that tagline, really what we mean is that we want to go through, we want to understand what it is you're trying to do, and then we want to go in there and co-design components that will make you be successful. So we can add value in several ways. Supplying components is one of them. Supplying that sounding board is yet another. I mean, it's a way to make sure that the customers are coming up with the best solutions. And really, I think by having this discussion gives the opportunity, to have a conversation with a subject matter expert to go in there and within these passive sum components and make sure that really what they're requesting really is the best solution. And I think the beauty of that is, the two heads are better than one, and we go ahead and we mutually talk about the solution and specifically within the conversation with how the system performance can be affected by TRM's parts. And by going through there, we can certainly come up with the best approach to solving the problem, whether it's an electrical problem, a mechanical problem, or an environmental sealing issue, or an environmental survival issue. Those are all perfectly valid and things that we talk about all the time with these meetings. I want to stress that it's not always about the electrical performance trade-offs that are made during these discussions. Very often it's packaging or a particular environment that the part is going to see going forward, and making sure that these parts can meet all those requirements.
Are there any additional or specific examples of how customers benefit?
Sure. There's many ways that customers benefit by having these discussions. What we then work towards is getting a total solution that's going to be optimized for these very specific program needs of the program. Basically, the benefit that another customer has is they have the ability to sit down and bounce ideas off a subject matter expert, and it's free. I mean, this is something that they don't have to pay for, and that it allows this very open discussion just to bounce ideas off of each other. And really, I think customers value the fact that if they have an architecture that they're beginning to work on, especially very early on, having an outside validation of the approach for how they're going to do it only helps relieve risk on their part. So as a risk reduction mechanism, I think the customers value that as well.
So if there's no cost, how does TRM benefit from these application discussions?
TRM benefits really on several levels. And I want to say that, the short answer is that TRM benefits by being able to supply a unique part for the program. Once we have a unique part identified on a drawing, that guarantees that TRM will be the vendor of choice for the life of the program. So from a sales standpoint, that is absolutely key to helping ensure that TRM will stay on the program for the life of the program. The other benefit that we have is that we enjoy solving problems and working with customers. This is something that TRM is configured very much to do, and part of our business model is to solve unique problems for difficult environments, and this approach allows us to accomplish just that. Once you get into solving these unique problems, customers are usually very much inclined to appreciate those efforts and are willing to pay a little bit more than what a commodity would be. So those are all things that benefit TRM in the long run.
Okay, and speaking of commodities, TRM also sells catalog parts. So I expect there might be times when that option is better for the customer.
Absolutely. Not all best solutions are custom solutions. And I think in going through this process, I think what we find is that very often a catalog part is really what the customer needs. And if that's the case, after going through the review, and if that is the best solution for that particular need, whether it be cost or testing or whatever else they're looking for, very often that will be it, and we're happy to sell catalog parts. What we do find though is that there's usually some additional value add that the customer, that the system is usually looking for over and above a catalog part. And that's really where TRM tends to be quite successful if there is some sort of unique identifying feature about the part that the customer requires. Sometimes it's just validating data temperature. Sometimes it is a little more involved than that. But these are the sorts of things that certainly TRM is positioned to do and are happy to do. Any of these value add services are something that TRM is configured to do, and we're happy to do that on a daily basis.
Okay, well, that makes good sense. And what about some of the additional unique things or differentiators that TRM brings to the relationships in these discussions?
Yeah, so TRM's business model really is to work with our customers to supply the best solution. TRM is a solution provider. We like to think of ourselves as a solution provider rather than a component manufacturer. We're a solution provider that also manufactures components. And I think that's really the way that the business is configured, and really working with our customers is how we can be that solution provider. In order to be a solution provider, you have to talk to the customer. So that really kind of flows that way. Part of things that makes us a differentiator is that we offer very unique mechanical packaging, as well as all of the objective evidence that our customers require to say that we meet all the requirements, whether they be electrical, mechanical, or environmental. So that is something that TRM is positioned to do and happy to do for our customers.
Okay, well, as always, Shaun, good information. Would you like to summarize?
Yeah, sure, absolutely. I think part of what we like to do here, and part of this whole discussion here, is we like to work with our customers. The earlier in the process, I think the more value add that TRM can have. But I think part of the way the customers benefit from that is they get the chance to speak with a subject matter expert in an area where they may not be or have available to them a subject matter expert for these sorts of components. And I think it's beneficial for both parties, both on when TRM goes to identify what parts we're going to build, as well as the system engineer who is trying to look to see to find the best solution for his unique problem, and making sure that he's specifying the optimum component. I think the other thing also that this leads to is the ability for TRM to customize our parts and offer unique mechanical or electrical or data to be able to go in there and really give us the ability to really hone in and give them exactly what the customer needs for the requirements, or whether that's a mechanical design issue, whether it's a testing validation, or some other sorts of data that needs to go along with the component to be used either just to validate that the part will be fully compliant, or whether or not they need that data as part of higher level integrations, whether it's through system simulations early on the program in the process, or later on as part of calibration tables and things like that our customers need to embed in software for system control sorts of things.
Okay, and I think we have time for at least one question, and this one is a good one. Not that they aren't all good ones, but I see that it's best to have these application discussions as early as possible in the process. But is it ever too late to have an application discussion?
Yeah, absolutely not. I think the earlier in the process, when the ink is still wet on the drawing board, those are really the best times to go in there before any sort of system decisions are being made. Those are clearly the best time to have these discussions. But actually later on, very often what we find is that there are other items that come up with requirements that are not always written down in paper. A good example that I like to bring up is that we were designing a power divider for a customer at one point, and I was traveling through the territory just as part of a routine stop. And I stopped in. I happened to see the customer, and I knew it was currently in design. And I asked the customer really what they were using the part for. And this is a part that they had fully spec'd out for us, and we were just building the part off the drawing. And it turns out that what was really important to that customer for the system performance was something that was not in the spec, and the approach that we were taking was not optimum for that sort of requirement. So we actually stopped the design, even though we were mid-contract, and made some modifications to the design to optimize those particular parameters that were not even specified. So I think that that's a good example of why these discussions are important, because they can certainly have a big effect on the final system performance. What I will say then is that a follow-up visit with that same customer, they were extremely happy with the performance of the part. It met all of their expectations, specified and unspecified, as it were, and the system was quite successful when they deployed it. So had that meeting not happened, the outcome might have been different for our customer, even though we met all of the requirements that were in the written specification.
Okay, well, I think that subsequent questions will be addressed through email. I want to once again thank everyone for joining us today. I think we can see the conclusions here on the screen from today's discussion. If you are a customer who would like to ask more questions, please call the engineering hotline. There's no charge for those conversations either. You can see the number on the screen, 888-677-6877. And I think that the goal here is for us to learn as much as we can and understand your ideas and then help you complete them. And maybe if it's applicable, to offer an engineering application discussion. And if you're one of our field sales representatives, then you know that your calls are always welcome as well. You can also submit questions directly through the sales rep portal or work through your CAM. And in case it's helpful, our next Tech Talk is at least tentatively scheduled for Tuesday, August 24th. And the focus will be on advancements in manufacturing technology. Shaun, as always, thank you so much. And again, thank you, everyone.
Thank you, Paul.